Okay, I think I'm going to actually answer parts B and C together because I think it will probably be relatively straightforward, and it's good to see it all as one kind of big picture. So, part B, find the tension in the string as A descends. This is what I will always do, just as we did in the question before. I'll look at the two separate particles, I'll look at the forces acting on it. First thing I'll do is just update. I know my acceleration is 3.2. Oh, it's a rubbish pen. 3.2. And this one's going to be going up at 3.2 meters per second squared. I'm struggling for space a little bit there. Right. First thing I'm going to do is look at A, particle A. Then I'll look at particle B. So I'll look at A. Right. Look what I do real carefully. I'm going to draw a box round this particle here. So this was particle A, wasn't it? Just looking at the forces acting on that. That tension isn't anything to do with this one here. So it's got a mass, its weight acting down, and then the tension acting against it, and that's going to be equal to the mass times the acceleration. So let's just resolve the forces first. I've got resolve, then I'm just going to call down positive for this one here, yeah? So I've got mg, and I've called down positive because that's the way in which it's accelerating. So down is positive. Okay, right. So resolve the forces. I've got mg minus the tension is acting against it. So that's the forces, the resultant force. So that's my F is equal to mass, which is m in this case, times acceleration, which is 3.2. Right, so we have basically mg minus t equals 3.2 m. So by elimination, I can't work out what this one is currently because I've got t, which I don't know, and I've got m, which I don't know. So, but that's going to help me. I feel like that's definitely going to help me for the second part. So now I'm just going to do 4b. I'm going to do exactly the same process. Look specifically at what forces are acting on this particle this time. So I've got, what am I going to call up? I'm going to call up positive because that's the way in which it's accelerating. So I will resolve upwards. So I've got T minus the weight acting against it, which is 3g, is equal to the mass, which I'm told this time is 3, times the acceleration, which is 3.2. So the resultant force equals mass times acceleration, and I worked out that acceleration in the first part. Okay, so all I actually basically need to do here is just add. I know what g is, that's not an unknown, that's 9.8, that's gravity, isn't it? So I've got 3 lots of 3.2, which is going to be whatever that is, 9.6. In fact, I'll leave it like that just so you can see what I'm doing. 3 lots of 3.2, add 3g is going to give you the tension, which is equal to newtons. Yeah? Okay, so now I've worked out what the tension is. I didn't actually need this bit here. Sorry. I didn't actually need this bit for A, did I, for that first part? I could have just looked at the motion of B because that was the one that helped me. But now I've worked out that T equals 39 newtons. I'm now going to use that and put it into the formula that I produced for A. So I'm going to substitute T equals 39. So just to be clear, that was for part B. And now this is for part C. I'll substitute T equals 39 into, my handwriting's really not this bad, it's just because I'm doing it all on a mouse, into mg minus T equals 3.2 m. Okay, substitute in what I've got. So I know that m, I still don't know what that is. That's the thing that I want. G minus t, which I've just worked out is 39, equals 3.2 m. Right, now I'm just going to put this on this side. So I've got all the m's on one side. So I'm going to have mg minus 3.2 m equals 39. The only way I can get m out on its own is if I factorize m. G minus 3.2 equals 39. Therefore, the value of m equals 39 over G minus 3.2. Let's check the mark scheme just once more. If you can hear that, as my baby in the background. 30, I've not just left him, by the way, he's with my wife. So equals, should be 65 over 11. I hope that that is the case. So 65 over 11 should be what this fraction simplifies to. The key bit in all of this, guys, was setting up these two equations. Always your starting point. Okay, right, and then, so when I work that out, that should be 65 over 11. I'll double check that that is the case before I upload this video. And then part D says, state how you have used the information that the string is inextensible. If it's inextensible, the acceleration of particle A is exactly the same as particle B, and we've assumed that. Therefore, that is what we should write. Okay, please email me with any questions. I hope you have a good day. Keep up the hard work.